This video is a clarifying lecture about labor demand. I felt that I was really unclear during the regular class lecture, so I'm recording this video to try to give you a much clearer lecture about labor demand. So the part in class that this is supposed to replace is the first part of what's listed in green here, which is analyze the labor market with supply and demand analysis. And I'm going to be talking about the demand curve part. So, labor demand. Labor demand decisions are basically made by firms. They are the ones who decide how many workers to employ, how many hours they should work. So why does a firm hire workers even though it must pay them? Well, it does so because it expects to receive more in extra revenue than it must pay the workers in wages. Now, what are our key assumptions regarding labor demand? The first is that firms maximize profits. That's similar to the assumptions that you would have seen in microeconomics. Second, adding more workers or hours increases output. We call this positive marginal product, that the adding an extra worker increases output. However, we're also going to assume that as we add more workers or hours, the amount of extra output we get from each worker or hour decreases. And we call this diminishing marginal product. We also assume that increases in capital or technology raise the marginal product of labor. Okay, so those are four really important assumptions that are underlying our model of labor demand. So let me give you a graphical illustration of assumptions 2 and 3, which is about the marginal products. Here's a graph that shows on the horizontal axis the amount of labor input, which we could measure in employment or we could measure in hours, and I'm going to call it N. On the vertical axis is Y, which is the amount of output that we get. Now, we've embedded two of the assumptions in the way that we've drawn this graph. First of all, the graph is upward sloping. It's increasing in N, and that's the positive marginal product assumption. Second, the graph is concave, which means that it's increasing at a decreasing rate. And it's that concave part that embeds the diminishing marginal product assumption. So let's look at an example. This is the same table that I had shown you before. And it shows the number of workers, the number of goods produced, the marginal product, and then the value of marginal product under the assumption that the price of output is $5. So when we add the first worker, we get a total of 30 goods produced relative to 0. So the marginal product is 30 minus 0 is equal to 30. We multiply that by 5 to get 150. If we are at 2 workers, we have total output of 55, and we see that the increment relative to 1 worker is 55 minus 30, and so then that means that the marginal product is 25. If we multiply that by that price of 5, that's 125. And we can keep doing that, adding more workers and seeing how many extra goods we get. Notice that I've embodied in this table two key assumptions. One is positive marginal product. Every time we add a worker, output does go up. But it's diminishing marginal product because that extra increase in output is getting smaller each time. And you can see that in the marginal product column. So to maximize profits, the firm should hire workers up to the point where the wage is equal to the price of the output times the marginal product of labor. So W is the nominal wage, P sub I is the price of firm I's output, and MP sub L is the additional number of goods, and that denotes the marginal product of labor. So let's go back to that same table and suppose that the wage is $75. How many workers should the firm hire? Well, if we look down at value of marginal product, because we know that we want to hire workers up until that value of marginal product is equal to the wage, we see that that occurs at 4 workers. So the profit maximizing number of workers in this case is 4. Now, if we look back at the thinking about marginal product, in fact, the demand curve is defined implicitly by the following condition, which is that the wage is equal to the price of output times the marginal product of labor. Since that marginal product of labor depends on the number of workers, we have an implicit relationship between wages and the number of workers. So let's take a simple example. Let's suppose the marginal product of labor is equal to 35 minus 5 times n, where n is the number of workers. Okay? So as long as n doesn't get too big, we're still okay here with positive marginal product. But notice that marginal product is negatively related to the number of workers, so that as n goes up, the marginal product goes down. That's just embodying our diminishing marginal product assumption. So if the price of output for this firm is 5, then the value of marginal product, which is the price times the marginal product, is just going to be equal to 175 minus 25 times the number of workers. Our profit maximizing condition for this example is then wage should be equal to 175 minus 25 times n. So we've implicitly defined a demand curve there. And in fact, we can graph it. So let's graph the labor demand for this example. All right, we know that the firm is always going to operate at the point where the wage it faces is equal to the value of marginal product, which is 175 minus 25 times n. Well, we can just take a graph and put the number of workers on the horizontal axis, that's the n, and the wage on the vertical axis. And if we graph this, it has an intercept of 175 and a slope of minus 25. And that's our labor demand curve. Now let's talk about real versus nominal wages. Okay, so far we've said everything in terms of nominal wages. So W is nominal. Now we usually want to talk about the real wage because we want to adjust for inflation. And the real wage is just the nominal wage divided by the price level. So let's divide both sides of that expression above by the general price level P. This gives us the real wage is equal to the relative price of the firm's output times the marginal product of labor. If we take this equation then, we can graph that just as we did before. The difference is that now on the vertical axis, we put the real wage, W over P. So now we can talk about shifts in the demand for labor. One possible thing that shifts the demand is an increase in the relative price of the firm's output, P sub I. Let's take our equation again. We can see from there that if P sub I goes up, that just shifts everything on the right-hand side up. So if we look at our graph, that's going to shift the graph up. Something else that could shift the demand for labor is new technology that raises the marginal product of labor for every n. So if we look at that in the context of our equation, what we're saying is that function MP sub L of n is going to be shifted up for every n if we get this new technology. Well, if we look at that on our graph, that also shifts the demand for labor out. So I hope this lecture on labor demand was a little clearer than what I did in class, and you can use this as a resource if you were feeling confused after class.